Ladies and gentlemen, here to welcome you to Centennial Central is AGU's past president, Eric Davidson.
Good morning. So I'm Eric Davidson. I'm the immediate past president of the American Geophysical Union, and it's my pleasure to welcome you today to Centennial Central. Throughout this last year, we've been celebrating our past 100 years of accomplishments and looking forward to the future of the next 100 years of Earth and space sciences. And this week, we've set up daily themes at this Centennial Central to help share new ideas, create networking opportunities, and collaborations. So today's theme is a blue theme, not politically speaking, but we are the Earth Covering group. And so our theme is Earth Covering, Habitability on a Changing Planet. And as we close out our centennial celebrations this week, I'd encourage you to visit this Centennial Central to meet new people and other disciplines on the other days that we're featuring in each of the 4 neighborhoods. I hope you'll see these thought-provoking sessions after fall meeting to inspire your future research, work, and collaborations. And I thank you for participating in AGU's centennial year. This work was done, this organization was done primarily by members of our council. And so I want to introduce now 2 members of our council who've done the heavy lifting for most of this work in organizing this, Petra Dekens and Catalina Oida.
Thank you, everyone, for coming. I can't quite see you. The lights are really bright up here. So welcome to day 2 of the Centennial. This is the Earth Covering. We represent 8 different sections within the AGU and nearly half of the AGU membership. So that explains the crowd that we have here today. I want to take a moment to thank all the leaderships of those sections and people within those sections for the tremendous amount of work that they did to put this day together and to organize the programming. And also a thank you to the AGU staff who kept us on task and who really did a lot of the heavy lifting. So you have the program in front of you, so I'm not going to summarize that for you, but I hope that you come away with a few key messages at the end of today. The first one is that our discoveries over the last 100 years have really been amazing. We've learned so much about our planet and about what makes it habitable and what makes it thrive as a place for us to live. Unfortunately, we've also learned a lot about how humans are impacting that habitable planet. And it's important to remember that the world that we were born into is not the world that we are leaving our future generations. But the work that we do on understanding the past and the present Earth is really what informs how we're going to build a more sustainable future. So today's scientific stories are going to be told from a variety of different perspectives, from senior scientists whose work have built the strong foundation on which we must build, to early career scientists who are looking towards the future and how the next 100 years of Earth and space science can build a sustainable future, to indigenous and community leaders whose perspectives on how climate change is already impacting people today should really motivate us all to work towards a sustainable future. But most of all, we hope that you leave today inspired. We hope you leave inspired to continue doing the great work that you're already doing, but to also think about expanding the way that we do science, to conclude a really diverse approach and perspective to tackle the world's most challenging problems. And so with that, I'm going to turn it over to Phil Mote, who's going to introduce the opening session of the day.
Good morning, AGU. It's my great pleasure to introduce our opening keynote, but before I do that, I want to describe very briefly how we got here. At the council meeting in March, we had a brainstorming session about how this day, the Earth Covering celebration, would go, and it was just a whole fireworks show of great ideas, and it got more and more frustrating that we didn't know anything about how we actually wanted this to happen. And so enormous credit goes to Petra and Catalina for corralling all these great ideas into some kind of structure for today. So I want to thank them heartily for their work getting us here. From March through the summer, it was really, really challenging, and I appreciate their leadership. And then Victoria Fiorini from AGU staff has lived and breathed, where's Victoria? Off making something happen, probably. Back there, okay. Let's give her a round of applause, too. Every detail, you notice we had music. She corralled people's ideas about different kinds of music that we could have during the day today. So this has been a tremendous effort on the part of a number of council meetings members, but especially those three. So I'm here to introduce Richard Algae, our opening plenary speaker. Richard, as many of you know, is the Evan Pugh Professor of Geosciences at Penn State University. He's exceptionally well known internationally for his work on the Greenland and Antarctic ice sheets, on their stability, contribution to sea level rise, and also on what particularly the Greenland ice sheet reveals about past abrupt climate change. He's had an enormous amount of public exposure. He's a very talented science communicator. He's won all sorts of awards, both for his science and for his communication. I won't list all of them, but some of the more notable ones. He is a fellow of AGU, of course, a fellow of the AAAS, a foreign member of the Royal Society, and a member of the National Academy of Sciences. So, Richard, let's kick off today.
Okay. Thank you, Petra and Catalina. Thank you, Victoria. Thank you, Phil. It's an honor and a privilege to be here. This theater has 400 seats, so there's actually a lot of you here, and that's a testament to the value of Earth covering. And we're streaming over there, and we're streaming across the street, so it's great. They asked me to talk about this, current problems facing our planet and society. I could give you problems. I can do collapsing ice sheets and taking carbon out of soils and amplifying the warming and abrupt climate changes. But instead, I think we're going to try to do something else here. And I was hoping that this clicker would actually advance things. It doesn't seem to be at the moment. So if anyone has, there we go. But what I'm going to do is give you an alternate title and see if we can do this. So we're going to talk about get rich and save the world, or else. Okay, so you know that we have an immense number of problems, and you could all list them. It's pretty easy to do this, but I'm going to start a little bit on solving problems, because we must, but we can. And so that's where we want to go. You know this, we have a lot of students in class, and the students will go out and get a job, and they will find a problem, and they'll go to the boss, and they'll say, here's my problem. And the boss will say, don't tell me your problem, tell me your solution. Right? And that's really what they're doing. They're being hired to make solutions, not to make problems. And if we are the people who make problems, it's difficult, right? So let me tell you a couple of stories of problems and solutions. You can probably tell what isn't falling out is turning gray. So I am from the era of BCP, before cell phones. I was not an early adopter, right? So, and the day came, I was going to give a talk down at the museum in Baltimore, and it was snowing in Pennsylvania, and I drove to Baltimore. And I got to Baltimore, and it was closed. The whole city was closed. It was just sort of flabbergasting. And so I found a payphone. If you're young, you should go watch Doctor Who to find out what a payphone is. But at any rate, I found a payphone. I call my dear wife, and she says, "You are getting a cell phone." Okay. They called her about 20 minutes after I left. It's too dangerous to drive. And so, I have one. You probably do too, right? So there's mine, and I want you to think about it for a minute. Just think about your cell phone for a minute, right? So what is it? And there's a little sand, a little quartz crystal or some sort in there for the glass and for the silicon in the chip. And there's some sort of organic matter in the plastic, which might be oil. And there's the right rocks, not these, but the ones with the palladium and the rare earth elements and what have you. And that's really all it is, plus science and engineering and design and marketing, right? And I want you to think of a world. There's a picture on the over here of a do-it-yourself cell phone kit. Now imagine the world in which those people could not go campaigning until they put it together. Right? You can't even imagine that world. The fact that we have these cell phones is just flabbergasting. And think about it a little bit. There's a computer chip in there. The computer chip is based on a transistor. The transistor is invented at that bastion of free enterprise, Bell Labs, which happened to have a government-granted monopoly. When it came time to commercialize it, where did the money come from? It was mostly from the Air Force, because they really didn't like shooting missiles that had vacuum tubes in them. It is designed with quantum mechanics, which is based on research from universities. Right? It is connected to the internet now, or whatever we want to call that thing of computers out there. When I first logged onto it, it was called the ARPANET. I was at Wisconsin, and we logged onto the ARPANET. I actually had the opportunity once. I had dinner with Leonard Kleinrock, a fantastic person who invented packet switching while he was at UCLA. Funded by the Defense Department, the ARPA, the Advanced Research Projects Agency, so that researchers at UCLA could talk to researchers at Stanford and Utah and Wisconsin and around the Horn, because making university researchers able to talk to each other was good for national security. Right? And the ability to do banking and to call down the AGU schedule on an app comes out of that. Right now, my dear wife and I have spent the last decade living with one car. The daughters took the other cars when they left, and so she drives the car and I bicycle. I rode 3,000 miles on my bicycle this year, so I got there. When I do drive, there's a nice lady in my phone and she tells me where to go. And I do what the nice lady says. Cindy, for a while, was using this Australian guy, and he'd say, "Turn right here, mate." But at any rate, you know there's a GPS in the phone. And when I first met GPS, this is the late Grady Ian Willens, he was my advisor. He was surveying the motion of Antarctic ice streams. He had to bring the data home and post-process them to learn where he'd been, because the ability to locate yourself rapidly and precisely was a national security secret. And so they were dithering this. It was called selective availability. And back when they finally people figured out how to get around it, then they sort of turned it off. But GPS is also a military program originally, right? And the GPS, as most of you know better than I do, it requires both special and general relativity. And the satellite is higher in the gravity well and moving faster than we are, so you need both of those. If we did not understand relativity, the nice lady in the phone would start to get lost in 2 minutes. Right? It is a truly amazing thing. Now, this is me in 1977, after my freshman year working for Ian Willens. I'm studying radar records of ice sheets there. We still do. But if you'd ask my professors, what are the physics we don't need, they would have probably said relativity and quantum mechanics. You have relativity and quantum mechanics in your pocket. You cannot conceive of the world without those, right? And how did we get them? We got them based on university research, seeded by the government and made useful in a private-public partnership which has national security as well as commercial applications. And it's not just a phone. It's medicine, it's agriculture, it's engineering, it's sanitation. You can do the list in your brain. It's a fantastic thing. I want to show you this. If you get a chance to go to the new Hall of Deep Time at the Smithsonian down in Washington, it is a fantastic triumph of getting a lot of our science available to the people. There's a little exhibit in the corner of it, which you can see here behind me. We snapped a picture when we were down there. When modern humans arrived in South America, 82% of the large species went extinct. When modern humans arrived in North America at 74, Australasia it's 97, right? It's lower in Asia and Africa because there was some coevolution going on. Modern hunter-gatherers were busily driving down the carrying capacity of the planet. Probably the population of the planet was a few million at that time. When we got to a few million, we were lowering the ability of the planet to support us. The carrying capacity of the planet for hunter-gatherers is probably only a few million or less humans. We are a few billion. We learn, we teach, we build, we grow, we clean up after ourselves, we get along with each other, and we have increased the population 1,000-fold. And we weren't sustainable at a few million. Whether we will learn to be sustainable at a few billion is our challenge. But knowledge is not optional. Learning and teaching and building and growing and cleaning up are not optional. They are absolutely essential. But we live in a world right now that I will open my phone and I'll turn it on and there'll be a nastygram on it that says, "You're an evil liar. You scientists don't know what you're doing. The government can't do anything right, and you should get out of our way." And a lot of us get these nastygrams from fellow citizens using a cell phone to tell us that scientists don't know what we're talking about. Right? And that is a challenge. Now, I'm going to show you a plot. I do not, please, don't take this and go do politics immediately with it. Don't blame me for being political. This is a challenge for us. The Pew Charitable Trusts people have been surveying what people think in the U.S. about many things. And one of the questions they've been asking since 2012 is, are colleges and universities good or bad for America? And this is the U.S. If you're from across the pond or somewhere else, I apologize for focusing on the U.S. But you have a little of this too, so just know that. And so they've been asking that. So over here are people who lean to the left politically, and sort of, 3-to-1 or so, they say colleges and universities are good for America. Over here, people who lean to the right, there has been a transition, and right now, by almost 2-to-1, they say colleges and universities are bad for the nation. Now, they're going to go get their life saved at a medical center that's attached to a college or a university, or some other medical center that's using discoveries that came from there. And while they're there, they're going to use their cell phone. But right now, by almost 2-to-1, they say it's bad for America. Okay? I'm going to show you this. I show these at a lot of talks. These are a couple years old now. They're from the great people at the Climate Communications at Yale. And this is it's just the U.S. Those of you from elsewhere, you're welcome to feel a little superior if you want to, but I'll guarantee you that there's some of this there too. Okay? So this is a map, and this is what people in the U.S. think about climate change issues. I'm going to make a point first. We humans really are influenced by peer pressure, and a map is a very, very strange way to look at the U.S. if you're worried about peer pressure. I come from Pennsylvania. There's a little dot over there labeled Philadelphia at the end of the blue arrow. There are almost 3 times as many people in that dot as there are in Wyoming. Almost 3 times as many people in Philadelphia as Wyoming. If you draw, that's sort of kind of the metropolitan area, Philly. I didn't quite map out every county. I drew a thing with a little cursor in PowerPoint. But more or less, that's the Philly metro area. There are more people in that blue circle than there are in those 6 states. right? But those 6 states have 12 senators and the little blue circle doesn't. So this is a valid way to look at the US, but it's not the only way to look at the US. It turns out that most people in the US accept climate science. They're fine with climate science. The people in most of the US are not so sure. And both of those statements are accurate. Most people in the US accept our science. The people in most of the US are not so sure. Now just remember that, and let's go forward now. So if you ask Americans, is climate changing? The oranger or redder is yes, and the grayer or bluer is no. Almost every county in the US, people say, yeah, it's changing. You can sort of identify the big university towns by the redder color. If you ask them, are humans responsible? Most Americans say yes. Most of America now is not so sure. Do scientists agree? Right, this is the paid disinformation plot. Somebody has done a really good job of amplifying a very small number of skeptical voices in a way that now a whole lot of people in America learned about climate change from scientists and believe they know more than the scientists now. Right, is it bad? Well, they're a little worried about this. And then the two that I want you to look at carefully. Should we do research on solutions? Should we do research on solutions? They're not even sure we have a problem, but yeah, let's go solve it. And the last one, are you talking to your neighbor about it? There is no county in the United States where the average person has talked to their neighbor about this. And you know what happens. You go home for Thanksgiving dinner and you say, how about that climate change? And Uncle Ed says it's an evil lie. And you say, it's okay, Ed, pass the gravy. And how about the 49ers? Right? A whole lot of people are convinced that we can solve a problem that they deny exists. A whole lot of people are convinced we can solve a problem that they deny exists, but nobody's talking about it. And if you want a challenge, if you want a problem to solve, there it is. How do we get through that, right? You get a job as a student and you say, this is my problem, and the boss says, what's your solution? I think that's the same thing. Our taxpayer bosses have said, don't tell me your problem, tell me your solution. You can look around AGU. There are people doing AGU climate solutions now. Keep an eye out for this as you go. But I think the message is very clear. Don't tell me your problem, tell me your solution. Okay? Now, let me do a history of energy, and then we'll come back to some things. The value of fossil fuels to us is fantastic, and that's one reason why this climate problem is so difficult. So I showed you just very briefly the price we paid for being hunter-gatherers of food. We are still hunter-gatherers of energy. We have solutions now. But let me walk you through this a little bit. Most of you flew into an airport. You go through TSA, you get your coffee, you find your gate, and then you look for a plug. And you can map plugs in most airports by just looking where people are, right? I apologize, if you're from any country except the US, these are kilocalories, and I apologize for the ancient units. A human diet is about 2,000 calories per person per day. If we put 2,000 calories out on this table and we burned it over 24 hours, the power is 100 watts. If I had to ride my bicycle to make the electricity to run the light, I would be out of breath. That's sort of all I can do. All of your brilliance is done with the same power as one old light bulb, which is truly right. A Tour de France rider can do 500 watts, but boy, oh boy, do they eat in the evening, right? So what can we do for ourselves is 100 watts or 2,000 calories per day. What is done for us in the United States is more than 100 times that. It's more than 100, right? What's burning to support me is more than 10,000 watts. And right now, it's about 83% fossil fuel. And we're well off because of this in a whole lot of ways. And this is why this is a difficult problem, right? Now, we have this amazing history. We're going to burn something faster than nature makes more. We suffer all kinds of problems while we're burning because of unintended consequences. Then we run out. We have conflict. We have government intervention. We have all kinds of problems. And then we find something else to burn, and then we do it over again. And this is really the history of humanity in some sense. Burn, suffer, run out, panic, burn, suffer, run out, panic, right? Okay. I came out here from Pennsylvania, from Penn State University. My mailing address is a town called State College. State College is a suburb of Penn State. You look at the dates they were founded, and Penn State is older than State College because Penn State was founded up the hill from the iron furnace by the iron masters. And when it was running, the iron furnace would have looked like this. This is Hopewell furnace. And they were turning red dirt and limestone flux into the iron that was used to build the eastern US. And they powered it like this. They were using charcoal. And you make a big pile of trees, and you bury it in dirt, and then you burn it with restricted oxygen to drive off the water and other things and make a fuel that will burn just hot enough that you can smelt iron. And it did this. A furnace, and the people who took care of it was a square mile of trees a year, 250 hectares of trees a year for one furnace and the people who took care of it. If you go to a map of Pennsylvania today and you say, where do we remember the name furnace on the map? All of these are furnaces that we remember. There's a whole bunch more that we don't remember. And over here are forges. You made pig iron, you shipped it to the forge, you turned it into useful things. Valley Forge. What's a forge? It's making useful things. Every line on there is a square mile, 250 hectares of trees a year, and then you got to wait 50 years until you can do it again. My state, the Commonwealth of Pennsylvania, it is Penn's Woods. When the European settlers arrived, they said that a squirrel could go up a tree on the east coast of the Atlantic and stay in the trees to the Mississippi. The first forester of the Commonwealth of Pennsylvania, a fellow named Rothrock, wrote about the Great Pennsylvania Desert. Now, it wasn't a desert, it still rained, but it was essentially treeless. We have 1 million deer in Pennsylvania. There might have been a few left 100 years ago. We have elk because we re-imported them from the Rocky Mountains. Pretty much, if it was bigger than a squirrel or a rabbit, we did not have it because we just burned it all. And it wasn't just us. This happened in China, this happened in Europe, this happened all up and down the east coast of the US. If you know Cape Cod, this is Cape Cod. This is East Ham. This is First Encounter Beach, where the Pilgrims first meet the native people. They said it was so goodly a land and wooded to the brinky of the sea. In the late 1600s, still in the 1600s, the town of East Ham outlaws their own ability to cut their own trees on their own property because deforestation had become so extreme that they didn't know what to do. It didn't help. The government got in people's faces, but they ran out of trees anyway. When Thoreau walks the Cape in the 1800s, he says, many of the people get all of their fuel from the beach. Either there's driftwood or you don't cook dinner. Right? And it's a lot of the wood they had actually used to boil seawater to get salt to pack cod for trade. That's a really inefficient way to get salt. And what they finally did to fix it was to go to renewables. They did windmills and solar drying troughs to get their salt because they didn't have anything else. All up and down the East Coast, you'll find the records of people running out of trees, then people getting really intrusive governments who have to deal with this issue because in times of scarcity, that's what happens. If you've ever tried to read by firelight, do 12 stitches per inch by candlelight on your quilt of a dark winter. It's really hard. Poor people used to use a biofuel called camphene. It would be a mixture of alcohol and turpentine, and it burned pretty clean, and it was pretty cheap, but it was sort of, it was white gas, it was explosive. And there's horrible stories. The Methodist minister and his wife go out to visit the parishioners. The 3 daughters try to refill the lamp, and it blows up and burns them to death. And so rich people burned whales. And you'd take lots of money and you'd ship it to US New England, and then they'd go out and they'd kill whales and they'd cook them, and then you could use them in your lamp. And this is the history of whale oil in the Yankee fleet. 1800 is over here, going over to 1880 over here. You can see they got good at whaling. It's a complicated story, right? Because somewhere about here, the fleet is crushed in the sea ice off of Alaska, and the insurance goes through the roof. But what's the fleet doing in the sea ice off of Alaska? There aren't any whales they can kill closer to home. Now, there were some whales that were too fast for these people, and so the Norwegians and the Japanese kill them over here, but it's the same story. You can see what happened to the price. It goes down to, at the minimum there, it is about $7 a gallon in modern money, so 8 liters, yeah. And then when they hit peak whale oil, it goes up to $25 a gallon. And then somebody went up the road from where I live, and they said, wow, oil is leaking out of the ground. And if oil leaks out of the ground, maybe there's oil in the ground, I should drill an oil well. At the peak, there are 10,000 sailors out of New England scouring the world ocean for whales. 10,000 sailors at the peak, 100 years of whaling, enough oil to replace our modern use of petroleum for 11 hours. Right? You meet the person, says, when we run out, we'll just go back. No. Okay, get real. But be clear, we have trees and whales because we burn fossil trees and fossil algae. And this is not a new idea. This is a piece that was published in the magazine Vanity Fair in the year 1861. So this is just before the US Civil War. And it was entitled The Grand Ball Given by the Whales in honor of the discovery of the oil wells in Pennsylvania. And if you're in the back, you can't see this, right? So just before the US Civil War, it says, the oil wells of our native land, may they never secede. Oil's well that ends well, we wail no more for our blubber. Right? This is a cover of a piece of sheet music from 1864. This is the American Petroleum Polka. We are going to dance to gushers. Right? And it's the oil well through pure oil 100 feet. Now, oil was always black. But, you know, the lady has got her pink dress on there, so you can't have black oil, so they made the oil white. But, but you're going to dance to oil. This is a great thing, right? The trees and whales grew back mostly in 100 years. The oil will grow back in 100 million. Right? Somehow the idea that we can choose between fossil fuels and renewables keeps coming up. This is, of course, absurd. There is not a hope of a sustainable future. We either burn and then we learn, or we learn while we burn. But if we burn before we learn, you know the story. We're going to change climate in the ways that make it hard to live on this planet for 10,000 years and beyond. We're going to change climate in ways that last longer than the history of civilization since those hunter-gatherers, right? The warming effect of our CO2, you all know this, the warming effect of our CO2 is not the least bit surprising. Arrhenius more or less had it right in 1896. The Air Force worked out the cross-sections in quantum mechanics while they were worrying about sensors on heat-seeking missiles, because CO2 absorbs infrared from everything. It doesn't care. The thing that's surprising is how much fossil fuel we use, how good the oil and coal and gas companies have been at supplying us what we ask for. And the numbers there, per person per year in the United States, we throw away 1/2 ton of trash. Per person per year in the United States, our share of the CO2 is more than 16 tons. 1/2 ton of trash, 16 tons of CO2. And that's the thing that's been surprising. It's not that CO2 warms, it's that oil companies have been really good at getting oil, right? So I'll come back to a bit of good news, but here's a little bit of problem. If we don't change what we're doing. The coming changes in the climate are bigger than what we've had. The past changes have winners and losers. It goes heavily to losers. The costs are superlinear in temperature, so each degree costs a lot more than the previous degree. And it might be a little better or a little worse or a lot worse. Right? That's the basic picture. We worry about heat stress. By late in this century, it becomes possible that places become fatal outside. You can't be there. Sea level rise, more floods, more droughts, stronger storms can get stronger. You lose one line of defense against tropical diseases. You stress your ecology, you drive extinctions, and you especially hurt poor people in hot places. Right? So that's what's on the table if we don't learn, if we don't use it. And I've got it, you know, I can go pull the stuff out, so can you. We all sort of know where to find the disaster stories, and we can give you chapter and verse on all this. I'm going to show you just a couple pictures on sea level rise, swiped from publications, and they're noted there. This is not a storm. This is a king tide. And this is not a canal, it's a street. And they are adapting to this problem by putting up no wake zone signs in the streets. Right? This is not a storm, it is a high tide. The octopus was not thrown into the parking garage by hockey fans, it swam in there. This is New Orleans. This is a hurricane that did not get into the city. It stayed out of the city. I would not have wanted to be the peace officer there who was looking over it. Under strong warming, we're almost guaranteed to get enough sea level rise that will get into the city by 2100. But there's a chance that we get enough sea level rise that it blasts out of the top of that picture. And that's the real worry. So there's some of you I know in this room who have worked with the IPCC, you've worked with the National Academies, you've worked with the Royal Society, you have helped assess the science on this. I had the wonderful opportunity to do the same. So this is us in Paris in 2007, and there's Peter Lemke, and there's Gabby Hegerel, and some amazing people back there. The IPCC, as you probably know, is the mother of all committees. Right? It is, if you printed out all the reports and you stacked them up, right? You know this, right? And we're almost always viewed as problems. We are the people that identify the problems, aren't we bad people? But imagine two futures now, one in which we use that knowledge effectively and one in which we don't. And if you were to take that pile of reports and turn it into a tweet or two, using the knowledge compared to not, we now actually know we get a bigger economy. We get more jobs, we improve our health, we improve national security, we clean the environment, and we're more consistent with the golden rule. That's really what the IPCC reports say, is if we use our knowledge effectively, we help economy, we help jobs, we help health, we help national security, we clean the environment, and we're more consistent with the golden rule. And I'll show you one slide on each of these, just for grins and giggles. Bill Nordhaus, I served on a committee with Bill once, amazing person, co-recipient of the Nobel Prize in Economics last year. He built tools that allow you to put climate change into macroeconomic analysis. Across the board now, those studies show that dealing effectively with climate change is economically beneficial. And economic optimization involves dealing with climate change. If you're into it for the money, you don't ignore this. You'll meet the person who says, oh, yeah, climate's changing, but we can't afford to deal with it. The Nobel Prize in Economics says you can't afford not to. Right? This is for the US, it's not the world. This is the number of workers in different jobs. You can see solar making electricity. You can see solar across the top. All fossil fuels together. Wind is bigger than coal. All right? The scholarship on this is a little thinner, but it is probable, you look through the IPCC, you read the impact stuff, it is probable that anything except fossil fuels makes more jobs. Right? These are a bunch of US medical organizations, and they said, hey, you know, Climate change poses a risk to the health of every American. It's every person in the world, not just Americans. And then their recommendation was, we believe the most important action we can take to protect our health is to accelerate the inevitable transition to clean, renewable energy. Right? These are doctors. This isn't me. A friend that served on this, actually, Dave Telly, the national security and accelerating risks of climate change, actions by the United States and the international community have been insufficient to adapt to the challenges with climate change. Strengthening resilience is critical, but you need actionable agreements on ways to stabilize climate change. These are military leaders. And they say they need actionable agreements on ways to stabilize climate change, national security. Right? This is one on environment. This is fairly old. You can argue about the exact numbers, but it gets warm and all those things in the mountains have to migrate up, and then they migrate off the top of the mountain and they're gone. And all those rare species in our national parks have to move somewhere else and they can't get there. And this particular estimate, a third of species are committed to extinction pretty soon if we don't get our act in gear. Right? And this one is fascinating. The top map is emissions of CO2 per person per year. Red is a lot. So the top map, if you're in red, you're changing the climate. If you're in blue, you're not much. The bottom map is an estimate of vulnerability to changing climate, mostly poor people in hot places. And what you'll notice is that top map and the bottom map are essentially just flipped. And if you care about ethics, if you care about the golden rule, if you're Jimmy Carter or Pope Francis or probably all of you, you look at that map and it bothers you. You sort of were taught that that's not how you're supposed to live. And so I put a quote from Pope Francis up there that you look at that map and you can't live that way. Right? So that's one slide for each of these 6 bullets. If we find efficient ways to use our knowledge, we get a larger economy, more jobs, improved health, greater national security, cleaner environment, more consistent with the golden rule. Okay? Right? What could we do? I am not the answer guy. I'm the problem guy. I'm sorry, but let me show you just a couple of things that come out of the solution space, and then I'll shut up and we'll have a discussion. So where do we get 2,000 calories per person per day? It's on this map. The orange at the top is croplands. More saturation is more of that pixel is in crop. This utterly hideous color at the bottom is grazing lands. And we let the animals eat grass, and then we eat the animals, or we squeeze milk out of them and eat that, okay? So we have changed everything in color on that map to get us 2,000 calories per day. If we took modern solar technology, the stuff that's on our roof at home, and we put it in a low-latitude sunny place, and we replaced every bit of external energy used by every human on the planet with a little room for growth, it is there. Right? Modern solar technology, that's more energy than we use for all humans on the planet. Now, don't kid anybody. If you compare the size of that square to the size of our roof at home, this is a 30-year task. It's a huge undertaking. But if you just want a scaling, what have we changed for food? What would we need to change for energy? There you have it. And you get to the point immediately of saying, wow, this might be doable, right? I had this amazing opportunity to make a PBS miniseries with Haines Stiles, who did the original Cosmos with Carl Sagan. And he took us down to Texas, and we talked to some ranchers who had saved the ranch, and they had saved the farm with wind power. They may not have known that Abe Lincoln loved wind power too. I've got a quote from him. Before he's president, he's out on the stump saying, we need learning, we need inventors, we need education, we need engineering, we need patents, we need wind. But what the modern Texas ranchers have done, they put about 5% of the ranch into wind power. They put 95% of the ranch into ranch, but the wind pays them a whole lot better than the ranch does. And they call it mailbox money. You go out to the mailbox and it's full of money. A wind farm on the windy parts of the plains and deserts of the world is 5 times human energy use. Right? The resource is there. This is something I swiped from the web from Lazard, the world's largest independent investment bank. This is for adding a little bit of energy to the electric grid. And what they have done is they have calculated, assuming that we got rid of all the subsidies for wind and sun, but we keep all the subsidies for fossil fuels. And I'll come to that in a second. And what you'll notice here, I just simplified their plot a little bit. This is the cheapest gas right there, and you'll notice that solar, utility scale, and wind are generally cheaper than the cheapest fossil fuel to add to the US grid right now. Now, that's not the full integrated system that's 100% replacement, but right now, is there economic competition? Well, you better believe it, okay? This is something from folks working with the International Monetary Fund, said, how large are our subsidies, global fossil fuel subsidies? They said, actually, if you include the externalities of fossil fuels, it's more than 6% of world gross domestic product goes into subsidizing fossil fuels. And that if we were to get rid of that in a good way moving forwards, that it has a huge influence on well-being and other things. Right? This is the newest thing that I've been seeing. This is not my area. I'm highlighting something that might yet poof out a little bit, but I thought it was really, really exciting, and I wanted to show it to you for a moment. This is an experiment that was done in Germany. They put some solar cells up high so that you could drive tractors underneath them, and then they had an adjacent area that didn't have the solar cells, and they did a controlled experiment, and they did the controlled experiment in a really hot, dry summer. And they got solar energy from their solar farm, lots of it, in a hot, dry summer. And they got more crop under the solar cells than they did in the control, because the water stress became, the heat stress became important. And so they're harvesting solar, and they're harvesting more food in that hot, dry summer. Folks at Oregon State have been looking at this, and they have been getting more meadow growth under their solar than they have not in a dry meadow because of the water stress issues. Right? And you can find this paper online if you look at it. Global energy demand would be offset by solar production if less than 1% of cropland is converted to agrivoltaics. Right? Fascinating thing. So be very clear. We're going to need a lot of fossil fuels for a long time. I'm not riding my bicycle home to Pennsylvania. I'm going to get on a plane the way that you are. We're going to need that. We're going to need to keep it going. The fossil fuels are important for our well-being, but they can't be sustainable. And we now have what would be needed to do that. There's a lot of companies, there's a lot of inventions on the way to doing that. We don't have all the answers, but our students are the first generation in all of history that knows they can do it. That it's there, that it's economical, that it's competitive, that we can build a sustainable energy system. And if we do, we can become energy rich. We can think about desalinating and pumping and irrigating. We can think about concentrating elements like phosphorus. We can think of a whole lot of things that eventually take care of the material well-being that allows us to get along with each other in ways that we can think about sustainability. So I'll leave you with a picture I took in Greenland a lot of years ago of an iceberg and a rainbow. Can we have a world with icebergs and rainbows? Yes. The problems are fantastically huge. The solutions are bigger. Thank you for what you do.
All right, always inspiring to hear Richard, the mix of science and solutions. I'm sure there are questions.
Yeah,
And we have a roving mic.
we do. There we
Over
go.
here.
All right,
Right.
thank you.
Hello. Hi. Thank you. I absolutely agree with you about the research. You know, from 1940 until the end of the 1960s, we invested 2% of our gross domestic product in research, and the world would just change. And since then, we backed off, and China and Singapore have picked up the song. My question, we're talking about solutions. I think one of the solutions is a bit of population control.
Yeah.
What's driving that energy is people. And apparently 45% of births are unintended. Aiming for that seems like an awfully easy target.
Right. So you're completely correct. Our impact is number of people times impact per person. We can work on either of those two. There's this, if you want to do the optimistic version, what we see worldwide is that people choose to replace themselves, and not more, if they are confident that the children they have will grow up, and if they have control of their lives and interesting things to do. And the control of their lives involves a whole lot of things to do with education, especially of women, making it possible for them if they wanted to go get it. But if we succeed in giving the good things that many of us enjoy to another couple billion people, the Earth stabilizes its population by choice. Nobody has to tell anyone to do anything. We're fairly confident that it rolls over because people choose that. And so the people in the solution space, trying to get clean water, trying to get food, trying to get education, trying to get empowerment to those in the world who don't have it, are probably the solution to population because it allows people to do what they want. So there's a cautious optimism in this. If we succeed in getting energy in control so that we can do food, we can do water, we can do fertilizer, and then a little bit of education, we win.
There's one right in front here.
Thank you for this talk. In an intro earth science class, maybe mostly with non-majors, would you lay most of this out for them at some point, or would you have them go discover some of it? How would you best motivate them to discover this information and take it forward?
Yeah, so how to do this in a class, far and away the best thing is to have them discover it for themselves. Some of us are fortunate to teach at schools who have small enough faculty to student ratio that we can do that, and others are not. So I lecture and write when I can't do better, and then I try to do better when I can. But I think, maybe we need to chat later because I would virtually guarantee you have better ideas than I do. Okay.
There was a question back by the booth.
Yes, so one of your quotes is that governments intervene more in times of crisis. What's your take on what the AGU and scientists can do in terms of getting government to intervene?
Right. So this is the challenge, and what I do is still I find problems, but then I cheer for the solution space. And I think AGU is doing, we have to have the knowledge. We have to know what happens if we don't take action. But I think you're seeing AGU starting to move more into the solution space. There are people going to make a lot of money forecasting weather for the grid at really, really, really high time resolution so that you can balance things in real time. And that's going to happen through AGU. We're going to have, if you're... How much wave energy? If you got to put up a seawall to protect your town from the rising seas and the stronger storms, are you going to put a wave generator on it or not? Can you sap the energy out of it? And I think there's a role for us in figuring out what the sea is going to do and what energy is available to tap into. So I think AGU just has to stay the course, but they have to keep moving in directions which they are moving, which is adding climate solutions to the portfolio. And I know that's going on. Jim Byrne has a couple sections later. There's other people here who are doing that. But I think we really do. AGU has gotten bigger in my life, but it needs to get a little bigger yet because it really does need to bring in those solutions people.
Hi. Very nice talk here.
Oh, there you are.
All
Sorry,
right.
they got the
So
mic.
my question is, according to your talk, and future seems to be bright in terms of how much energy we can harness from wind and solar. And could you comment on more about the problems and solutions regarding energy storage and transportation? Shall we be worried about one day we will run out of the minerals or we're used to make batteries?
Yeah,
Thanks.
so I think we should be worried about that. My impression is that we can get there. So the batteries right now, we're using a lot of lithium. You talk to a lot of folks in material science departments that are working really, really hard to get to things that have greater abundance. And people working on recycling and so on. We probably can make it work with what we have now, but we almost certainly can invent better. For grid scale storage, battery, think broadly. Battery might be pumping water uphill, and it might be splitting water and making hydrogen and using that, and it might be splitting water, making hydrogen, combining the hydrogen with CO2 and making our own liquid fuels. Broadly, if you think about energy storage, we have not worked very hard on that yet. A few years ago, I had looked at what we had invested in research. And at that point, we were not, the total amount of investment in energy research back in 2008, 2009, something like that, was just a drop in the bucket compared to any measure of our economy. It was tiny. And it was primarily dominated by fission, fusion, and fossil fuels. We were putting more money into each of those than we were into all renewables put together. And that has changed a little bit now, but I think seriously, if you turn the material scientists and the engineers loose on this, we'll solve it. And right now, you can see the problems, and I think they're real. And there are problems with rare earth elements, there are problems with lithium. I'm actually more worried about phosphorus, to be honest, for fertilizer. But I think we'll figure it out. And I think that the portfolio of possible storage solutions is so huge. There are occasionally times and places already that the price of electricity on the grid goes negative. There's so much electricity on the grid that you have to pay somebody to turn off their wind turbine so that you can keep it balanced. If engineers, if scientists, if entrepreneurs knew that there would be really cheap energy on the grid, can they find something to do with it? You better believe it.
Gentlemen, we have time for one last question, please.
Hi, so I was a bit late to the talk, so I'm not sure if you covered this, but where do you see the place for nuclear energy in this, and say this important transition from fossil fuel to something a bit more carbon neutral or carbon negative? Where do you see nuclear that can already provide the huge loads that we need right now?
So I showed you that we don't need it. There's enough sun to do it with sun, there's enough wind to do it with wind, there's enough nuclear to do it with nuclear. So it's a choice of how to do it. The sort of, we must do X because there isn't enough in Y, actually is wrong. We don't have to have it. Full disclosure, my brother works for the Nuclear Regulatory Commission. He's great, and he's really good, he's really important. The nuclear question, in a room full of people who want solutions, the nuclear question is the one that will turn it into an argument. And my gut feeling is that means that we're not at the point where nuclear can really be a part of the solution fast, because it's so hard to get there. And right now, running existing nuclear is just barely competitive with the cheapest renewables. Building new nuclear is nowhere close. So personal opinion is you keep running what you're running safely and make sure that my brother has a job so that you can do so. And that you go back to the drawing board on how you make it more useful and see if you can come up with something that would be economically competitive. So that's an opinion. I'm not an expert on that, but that's where you'd get from me. And that's one that you can all discuss on the way out, because like I say, it's just fascinating what happens in audiences when you bring up the nuclear issue, because there's people who are desperately convinced it's a win, and there's people who are desperately convinced it's a loss. The worst thing that can happen if your wind turbine breaks is it falls on your head. And the worst thing that can happen if your nuclear plant breaks is worse. So there are issues about trust and getting along with your neighbor, and will everyone agree that my brother has to be an inspector there to make sure that no one cheats? And there's a lot of issues that come up that are worth discussion.
And on that note, let's thank Richard once more.